Okay, this is AP, AB, and BC. We are doing Unit 2, Section 3, which is estimating derivatives of a function at a point. Okay, so let's dive right in. So uh, what we've discussed is that the instantaneous rate of change, or the derivative of a function f, evaluated at a point, can be approximated using what we would consider to be old school slope, right? So what we're going to do here is if we want to find f prime of 3, you'll notice that 3 is not a point on the table, right? But what you'll notice is if we, sorry, we're beach balling. There we go. So 3 is not on the point, but 2 and 5 both surround x equals 3. So I'm going to use the point at x is 2 and the point at x is 5 to approximate f prime of 3. So my f prime of 3 is not equal to, but is approximately the old school slope between the 2 points that I circled, right? So 5 minus 2, right? So that's going to be a -1 minus a 4 over a 3. So we're going to get -5/3. So when you're asked to approximate a derivative at a point, you're basically finding old school slope. That's sort of the gist of it. Now, sometimes you'll see this in the context of a word problem where x might have units of time and f of x might have units of volume or units of distance or whatever. Or position, or however it's measured, and you'll be asked to find the approximate derivative with units, but it's the same idea. Approximating a derivative is generally just using old school slope around that point. So let's go ahead and try a P1. Okay, so you're going to estimate f prime of 7, right? So again, you're estimating the instantaneous rate of change, or the tangent slope at 7. Pause me if you don't want me to do this problem. So 7 is not given as a choice, but 5 and 9 are, and they are both on both kind of flanking 7, right? So my f prime of 7, sorry, that prime is a little bit weak, all right, should be approximately f of 9 minus f of 5 over 9 minus 5, right? And I would suggest that you show this step just to make it clear that that's what you're doing. Presumably an AP reader would be able to pick up on what would happen if you just plugged the numbers in, right? So you're going to get a -4 on top of a 4, or a slope of -1. So f prime of 7 is approximately a -1. All right, moving on. So now let's do one that has some context, because it's very likely on an AP that you're going to see a problem like this where there's some context for the problem. So water is leaking out of a 50-gallon tank. The volume of water in the tank in gallons at time t, which is measured in hours, is given by W of t. So this is my volume, right? W of t is volume. Select values of W of t are given in the table below. Use the table to estimate W prime of 4 and explain the meaning with units. Okay, so notice, first thing I want to see is that I'm estimating W prime of 4. 4 is not on the table, so I'm going to use the 2 points that are sort of flanking t equals 4. So my W prime of 4 is going to be approximately W of 5 minus W of 3 all over 5 minus 3, right? Which is going to be 15 minus 26 all over a 2, right? So that should be a -11 over 2. Now, in terms of units, we know that the top was the Y values, or in this case, the W of t values, which would be gallons, right? And the bottom was measured in hours, so gallons per hour. So then the question is, what does this mean in context with the appropriate units? Well, if W of t is the volume of water that is in the tank, right, then W prime of t is the rate at which the water is leaking out of the tank. So water is leaking out at a rate of approximately 5.5 gallons per hour, or you could leave it as 11 halves, right? 5.5 is fine, or 11 halves, at hour 4, right? So you want to include the units, right? Now notice I didn't write it as negative here because the words leaking out included that negative. The reason that this is negative is that the volume is changing in a negative way, meaning the volume is getting less, right? There's less water in the tank. So when I say it's leaking out at a rate of 5.5, the leaking out covers the reason why this answer was originally negative, and I want to make sure that I'm clear that it's happening when t is 4, okay? So let's go ahead and do a P2. A balloon is being filled with air. The volume of air in the balloon in milliliters at time t in seconds is given by A of t. So again, A of t is the volume. Select values of this volume A of t are given in the table below. use the table to approximate a prime of 2 and explain the meaning using appropriate units. So again, we're looking for estimating a prime of 2, which means we're not actually finding the derivative of 2, we're finding the approximate value, which would be Oldschool Slope. I use the 2 points that would surround t equals 2. So my a prime of 2 should be approximately a of 3 minus a of 1 over 3 minus 1, right? So that's going to be 12 minus 5 all over 3 minus 1, which should give me 7/2. The volume on top was in milliliters, the time was in seconds, right? So that's my approximate value. And what this is saying is that the balloon is being inflated, meaning the air is going in, right? So the air is going in or inflating, right? So the air is inflating. The balloon, that's not how you spell balloon, at a rate of approximately 3.5 milliliters per second, or you could use 7/2 when t equals 2 seconds, right? And I suppose if I want to be picky, I should go back to this last one. Oh, I did say hour 4. So you just want to make sure that you have units. So that's kind of the gist. Now, you're very likely to see this E2 and P2 level stuff on an AP exam. You'll also see it in contexts where you're asked to do other things, because later on in calculus, we're going to learn how to estimate things like area under a curve from a table. So it's likely you'll be asked to do this and other problems that you don't know how to do yet. But we want to know that when we're asked to approximate a derivative, we are using Oldschool Slope from points that surround the point we're looking at. Okay, so moving on. So your calculator has the ability to find an instantaneous rate of change, or the derivative, at a given point. To be clear, your calculator cannot find instantaneous rate of change in terms of some x, right? Even for a really simple function. So several years ago, just for fun, when we were doing AP Calc Review on a weekend at Temple, when I had a lot more time in my life and didn't have a wife or a child, one of my students was trying to use Siri on his phone as a joke to see if Siri could calculate the derivative of x squared, which is a really simple derivative once you know how to do it, and you don't yet officially, but it's going to be really easy, and the answer is going to be 2x. And the phone struggled and struggled and struggled. Now, this was many years ago, and I'm sure that like the artificial intelligence behind things like Siri is better now. But something that my student could do almost instantaneously in his head, the phone just could not do. And so one of the things I want you to be aware of is that your calculator and all graphing calculators and the internet and phones, all sorts of things are really useful, but you still have to have a brain, and some things will be better and faster with your brain than they would be with whatever technological resources you have. So what I want to do now is I want to focus on what you can do with your calculator, because this is going to be a skill that's absolutely required. So here's the idea. There are 2 ways to differentiate on your calculator, right? So you can differentiate, but you have to differentiate at some point, right? Some point like f of a. You can't find f prime of the variable x. You can differentiate at a point. So there are 2 ways to do this. One is called n-derive, which is math 8, and I'm going to walk you through what that looks like in a sec. And the other one is dy dx, and you do that after graphing. So we're going to walk through both methods. So I'm going to show you how with both of them to find f prime of 4 using this function, right? So I'm going to go ahead and I'm going to put this function into y1 in either case, because to be honest, it makes my life a lot easier if it's already in here. So 0.75 x to the third minus a 5x, okay? So that's my y1, okay? So I'm going to put this in. I'm going to put this in as my y1, right? And then after I put this in as my y1, right, I have 2 options. So let's walk through the n-derive, the math 8 option first. So I'll go ahead and quit out of this, right? So if I want to use n-derive, I'm going to press math, and I'm going to press, you can either scroll down or you can just press 8. So there's n-derive, okay? Now I'm in the classic version of my calculator, I believe, unless, yeah. So I can show you what it looks like when you use the non-classic version, when you use the math print version, but what I will say is it's pretty intuitive if you're using the math print version. It is much less intuitive if you're using the classic version that I grew up with when I was using the old school calculators. Now, you might say, okay, Hogan, but then why would I use the classic version? Well, what if your calculator dies on an exam and the only loaner calculator that the teacher has in the room, or the loaner that you borrowed from a friend in advance in case, only has classic? Because some of the older calculators only have the classic version. So my suggestion is that you make sure you know how to enter it in a classic mode, even though your calculator might have math print, because if you can, math print is intuitive and looks just like what you'll see in handwriting. So anybody can figure that out if they have enough mathematical knowledge to understand the context. But classic mode is not like that. You really do have to know sort of what you're entering into what spot in the algorithm. So, okay, so when I do n derive, right, so what I'm going to do when I do n derive, let's, okay, so when you do n derive, here's what's going to happen. You're going to have the function that you're differentiating. You're going to have the variable that you're differentiating with respect to, which is almost always x. And then you're going to have at this x equals some a, right? So what this is going to look like when I put in this f prime of 4 is I'm going to use y1, and I'm going to show you how to do that. I can either use y1 because I entered this in as y1, or I could physically type in 0.75x to the third minus 5x for this entire first spot. And then since I'm doing it at 4, I'm going to type a 4. So let's go ahead and go back here. So if I want to get to the variables, to the y-vars, I'm going to go to vars. I'm going to go over to y-vars. I'm going to pick function, and I'm going to pick 1. The comma is its own button right above the 7 with respect to x, comma at 4. And if I hit enter, it's going to tell me that the derivative of this function evaluated at 4 is approximately 31 point bunch of zeros, so I can say 31.000. So if I do that, I get that f prime of 4 was approximately 31.000. Now, your calculator is not actually differentiating. Your calculator is approximating the derivative at a really high level, which is why, although the answer is actually 31, it's going to show you 31.000 because your calculator is doing a high-level approximation. Now, that's one way to do it. And again, just to be clear, if you had if you'd chosen instead, so I'm going to hit second enter, if instead of doing y1, if I wanted to type in the whole function, so if I wanted to type in 0.75x to the third minus 5x, I'm going to get the same answer, still the 31. I just think it's, so my suggestion to you is that this gets really cluttered and complicated, so it's a lot easier, especially when the functions get really ugly and have division, if you put the function in as y1 or y2 and so on. Especially when we get to problems where you're going to be differentiating multiple functions at the same time, you're going to have a much easier time if you do y1, y2, etc. Okay, so that's one way to do it. And just to show you what this would look like if I go to classic mode, or I'm sorry, if I go to math print mode, I'm not a fan of math print because I think you should know how to do it the old school way in case, as I mentioned, your calculator dies. But this is what it would look like if I use the exact same function in math print. Instead of n derive, you get this d dx. So if I go to math, if I go to math 8 now, let me show you what it looks like. See how, if I do math 8 in this math print mode, I'm going to put d dx, right? This is the variable. I'm going to put vars over to function, pick y1, and I'm going to say that I want to do it when x is 4. And that's going to be the same thing. So the reason I'm suggesting that you should get used to classic is I think you could logic your way through the math print mode, but I don't think you can logic your way through the classic mode. Now, I mentioned that there were 2 ways to do this, and again, we're going to be doing problems of this, but I just want to make sure you're familiar with this concept. The other way to do this is to put your function in your calculator and hit graph. Okay, there's my function. If I then go to second calc, you'll see that number 6 is dy dx. So I pick 6, right? And then I'm going to do at x is 4, and there's my dy dx, okay? So that's also completely fine, right? So if we put this up here, right, the other way to do this, right? So the other way to do this, if you wanted, that's way too small. There we go. If you wanted to do this using the calculator dy dx method, which is fine. So if we use this method, right, I'm gonna graph it, right? Then I'm gonna go to second and calc, and I'm gonna pick 6, which is dy dx. I then have to type in the x coordinate where I want to differentiate. So again, I go to second calc, I pick 6, but that didn't give me a derivative yet. I then have to hit the x value I want and hit enter, and it'll say dy dx is that value, okay? So I don't like this method as much as the n derive in most cases. The reason I don't like it as much is that as we start to introduce multiple functions at the same time, I think you're going to find it's easier to do n derive. But either of them's fine, and you do want to be able to differentiate at a point in your calculator. So let's move on to an example 3. All right, example 3. Given this function, we're going to find f prime of 2 using a calculator. So what I'm going to do is I'm going to go to my y equals, right? Oh, quick side note, if you see trig functions, right, it does matter that you're in radian mode always on the AP Calc test. So I'm probably in radian mode on the calculator now, although it's hard to know because in pre-calc sometimes we're in degree for a little bit. So I am in radian, so I go back to my y equals. I'm going to type in an x squared plus cosine of 2x, right? Now, I quit out of this. Now, here's the thing. If I want, I could hit second enter because I just did n derive. I already did that, right? So I could just do second enter and change this to 2 because I wanted f prime of 2, right? And that would be fine. Sorry, ignore that. I could just change it to f prime of 2, and that would be fine, and I'd hit enter. And I'm going to get that it's approximately 5.513, right? So my f prime of 2 is approximately 5.513 or 4, depending on if you round or truncate, and that's absolutely fine, right? The nice thing about this is if you're doing a bunch of these problems in a row, you've already differentiated once with y1, and you're just using y1 again, so I can just hit second enter. There's nothing wrong with typing this entire function. There's nothing wrong with typing this entire function, sorry that the thing is still beach balling, instead of y1, right? You could type this whole thing in. I think it's easier to not have to do that, right? Now, if I had chosen to do it the other way, again, you don't need to do it in both directions, right? But if I had chosen to do it the other way, I would go to graph, right? I would do second calc. I'd pick dy dx, which is 6, and then I would want that at x is 2, and I'd hit enter. And then sure enough, I get the same answer, right? So it doesn't matter which way you do it. I promise you just want to be able to differentiate at a point, right? And this is definitely a skill that you'll need on the AP. You're going to need to know these values sometimes that you can't calculate by hand. All right, so you go ahead and give P3 a try. It's the same idea. You can pause me if you don't want me to do it before you get a chance. So I'm going to go ahead and put this in as my y1, right? I'm just going to go ahead and change my y1 to be an x to the third minus an e to the x plus a 5x, right? And then I'm going to quit out, and then again, I can be pretty lazy because I already did an n derive, so I could just hit second enter, and that recalls what I did, and I changed the 2 to a 5, and that's pretty awesome. So if I do that, I get this value. If I do it the other way, right, so that's the one option. If I do it the other option, right, if I hit graph, right, I can hit second calc. I want 6, and I want to do it when x is 5. And sure enough, same thing, right? One caveat about using the graph method, and I want to double check that this is true when I say it. I think if I wanted a point that's not on this window, it's not going to work. So if I did second calc and I pick 6, but then I try to pick an x value that's not in the window from -10 to 10, so let's just say that I pick -15, that's not what I meant, -15, right, which is definitely not in the x window, and I hit enter, it may give me an error, right? So the caveat about using the graph method is that in order to use this graph method, right, in order to use that graph method, right, so for this one, in either case, right, so in either case, my answer is f prime of 5 is approximately, and then I want this, and whether I round or truncate, it's going to be about the same, because it doesn't matter, right, because that one is going to round and truncate to the same thing. So if you use this method, right, this method only works, right, so method must use an x in the window that's in your graph. So because this goes from -10 to 10, if I were trying to find f prime of something outside of that window, I would have to change my window so that it was included. Not a big deal, but it's just an extra step that I want you to be aware of if that's the method you're picking, okay? All right, so let's go on to the next one. All right, so we have this green curve, f of x, and we have this purple curve, g of x. Let h of x be the vertical distance between the two functions. Use your calculator to find h prime of 3. Okay, so here's the trick. And I didn't draw this great when I put these vertical lines on, but they're supposed to be vertical. So h of x is going to be the vertical distance, which has to be positive, right, between these two curves. So the trick is that h of x is actually the absolute value of one of these curves minus the other. And it doesn't actually matter which order you put the two curves in, right? But it's the absolute value because h of x is a vertical distance. It's always going to be positive. It doesn't matter which curve's on top. So here's what I'm going to suggest you do. I'm going to suggest that you put f in as y1, you put g in as y2, and then you make h of x, y3, equals the absolute value of y1 minus y2. Right? That's what I'm going to suggest that you do. That's the easiest way to deal with this problem. So I'm going to go ahead and put my functions in, right? So I'm going to put in 8 minus 0.5x squared, right? And the big trick here is to make sure that you put in everything correctly, because the most annoying part of this problem is going to be if you put something in wrong. So 0.25x cubed minus 2x squared plus a 9, right? And then in y3, I'm going to go to math. I'm going to go to number and pick 1, which is absolute value. Then I want vars, so I go to vars over to y vars. I want y1 minus vars over to y vars, pick function y2. And that's going to give me my h. So now what I want to do is, now that I know that y3 is what I want, the thing I want, h prime of 3, should be approximately what happens if I do n derive of y3 with respect to x at 3. Now, the AP is not going to give you calculator notation credit. What the AP, the AP is going to want to see, sorry, we're beach balling again. The AP is going to want to see the answer, right? So this doesn't give you credit. This is no AP credit. Sorry, the thing is glitching all over the place. So this is no AP credit, right? Like, you have to know that that's how it works, but calculator syntax is not going to give you any AP credit. So if we pull this up for a sec, right, so I'm going to quit out of this, and I'm going to go ahead and hit second enter, because here's the thing, I've already been typing n derive. Why make my life harder? So I'm going to go replace this y1 by going to vars, y vars, function, and I want y3. And I want this specifically at the point where x is 3. Now, it might take my calculator a minute because this is a pretty complicated function, right? So the more complicated things are, the longer your calculator thinks. In this case, it did not take very long. Good on you, calculator. But sometimes it does. So I'm going to go ahead and drag our answer over here. And when I write my answer out, I'm going to get that this is so I have two options. I can either write 2.249, or I can write 2.250, right? Because this would either round or truncate. If I truncate, sorry, meant to cut here. If I truncate, then it's 2.49, and if I round, it's 2.50, right? So either of those would be acceptable, right? So it's either, and I'm just going to put, actually, I don't need this piece. I'm just going to say, hey, I would accept a 2.249 or a 2.250. So it is a little more complicated if you do it the graph method, and this is why I mentioned that I would suggest the n-derive method. If I want to do the graph method, I'm going to need to turn off the two that I'm not using, right? So I'm going to need to turn off the two that I'm not using. I'm going to go ahead and hit graph, right? Now I'm going to go to second calc, and I want 6. And then I want this at 3, and that'll give me my dy dx. It's the same thing, but what I want to point out to you is that I had to turn off the other two graphs, because otherwise it would be unclear which function I was trying to differentiate, okay? So I really do think the n-derive is the best method. All right, so I'm going to give you a P4 to try, and then that's going to be it for this video. So P4, same idea. H of x is the vertical distance between these two curves, right? So you can pause me if you want. I'm going to use the same approach. This is definitely a calculator problem, right? So I'm going to call this my y1. I'm going to call this my y2. That's not the number I meant to write, which means h of x is going to be the absolute value of my y1 minus y2. Actually, shouldn't use calculator syntax. My h of x is going to be the absolute value of f of x minus g of x, or g of x minus f of x, it doesn't matter which means that what I'm going to put in my calculator is abs y1 minus y2. Now, the one nice thing about this, if you just did the example with me, I mean, I certainly did do the example, is that I just have to change my y1 and y2 because I already have y3 in as this exact thing. And then to find h prime of -1, right, what I'm going to do is I'm going to do n derive y3 with respect to x at -1, and that's going to give me the value I want. So I'm going to go ahead and change my y1 and my y2, right? This is going to be an x, not what I meant, my bad, x to the third minus a 5x minus a 1, right? and this is going to be an e, so second natural log, e to the x minus 0.2x minus x to the third, and then just double check that you have those right. All right, and I'm going to quit out of that. And then I'm just going to hit second enter because I already did all this work, and then I'm just going to change that 3 to a -1 and close the parenthesis and hit enter, and there's my answer. So, and again, you can do this by graphing, but I'm going to suggest that if you do it by graphing, that you're going to have to turn off the other two curves, right? So, and notice that if I round or truncate, I get the same answer because that 2 doesn't change the value of the 1. So that's my h prime. Cool, so that is Unit 2, Section 3.